Normalization.
Hmm.
Okay, so we start normalization in RDBMS. Normalization. No, what is normalization? Basically,
Hmm.
first check what is relational database design,
Hmm.
informal design guideline, semantics of relational attribute. सारे के सारे एक बुक्स है जो बुक से ये कॉपी करके बनाए हैं, मतलब ये पीपीटीज वो है।
Hmm. Hmm.
मैंने वो अपना means I have give you the reference of this book too before the classes start. That is Navate, Elmasari Navate.
Hmm. Hmm.
Okay, Fundamentals of Database Management System, Elmasari Navate.
Hmm.
तो वही से they have made these PPTs from there. The terminologies are similar
Same. Hmm.
in
Hmm.
that
Hmm.
book. Okay, so what is normalization? See, the chapter name is normalization. Normalization is basically it is a process of
Hmm.
uh, certification. You know, just like
Okay.
you are doing MCA. Okay,
Hmm.
maybe mm, maybe you know many things about computers, computer application.
Hmm. Hmm.
Okay, maybe you know some programming language, maybe you know DBMS, maybe you know algorithms, everything you know,
Hmm.
but you
Hmm.
do not have any MCA degree in your hand or any
Hmm.
computer related degree in your hand.
Hmm.
Then you cannot express, or if you want to go, if you go somewhere, okay,
Hmm.
and if you tell there that you know
Hmm.
computers, then you have to express lots of things that I know
Hmm.
this programming language, I know DBMS, I know that of thing. Okay, but if you
Hmm.
provide, on other hand, if you provide a simple MCA certificate to their hand, they will understand. Okay,
Hmm.
you know everything in computer
Hmm.
application. So what is this?
Correct.
What you are currently
Hmm.
doing, this MCA course, it is a certification process, right? So
Yes.
that certificate will tell everyone that you know all those things. Okay.
Hmm.
So normalization is something like that. It is a certification
Hmm.
process.
Hmm.
Certification process of what? I can
Computer
say
application.
it is a certification process. Okay. Now certification process of what? For database design. Okay. You
Hmm.
remember in our ER diagram class. Okay.
Hmm.
What we did in our ER diagram class? In our ER diagram class, we construct the DBMS. Na?
Yes.
We construct the architecture of DBMS. DBMS का मतलब कि एक database का जो design होते हैं, मतलब the design of
Hmm.
the database has been implemented or has
Implement.
been
Hmm.
analyzed and constructed in that part. Okay, ERD
Yes.
was the tool to design the entire database
Database.
for any
Yes.
application, right?
Hmm.
Okay, now see, after designing the database,
Hmm.
you have to confirm something. Okay,
Hmm.
you have to confirm in terms of application, right?
Hmm.
Eh, you have created a database, but how well you
Hmm.
have created the database, that has not been defined. Na?
Yes.
Okay, suppose you designed a bridge, you are a civil engineer, okay, and your
Hmm.
responsibility is to design a bridge, road bridge. So
Hmm.
your responsibility is to construct a road bridge, okay. So you
Hmm.
design the bridge, okay. Now after
Hmm.
design is completed, you just go and construct the bridge? No, Before that, your design must be passed by the,
Approved.
yeah,
Mm.
that must be passed by the government agencies.
Mm.
The how well your design is, okay, the later
Mm.
processes will depend totally on that.
Mm.
Okay, so same thing in case of database design. See, when for application
Mm.
development, okay, application development.
Mm.
So there are some processes. First, client interaction. Okay, after that,
Mm.
we take all the data from client side, analyze the data. Okay,
Mm.
analyze the data. After analyzing the data, there are multiple steps here. After analyzing data, we construct a database
Mm.
first. Means what are the data that need to be,
Used.
uh, these are some task analysis and data analysis, you can say. So
Mm-hmm.
this is your database. So
Mm.
how the database will look like, okay.
Mm.
But when you designing the database, after that, say here you finalize your database, here you finalize your task.
Mm.
Now this
Mm.
database is going to be used by the developers to
Mm.
build the application, na?
Correct.
Now this application development has several processes, several tasks. Okay,
Mm.
after completion, this is your final product.
Mm. Correct.
Now here, in between there are many steps. Okay,
Mm.
many manpower has already been engaged to develop this
Mm-hmm.
app. This is your final product. Okay, this is your app.
Mm.
Now while using the app, you are facing some problem, and after
Mm.
analyzing you find that the problem is coming from the wrong structure of the database or some discrepancies over there in the database design. Then what you will do?
Mm. You need to
Then what you will
perspectives.
do? Now,
Mm.
at this point of time, if you are modifying the structure of the database or trying to remove the discrepancy from the database, then you have to do
Mm.
many tasks again here,
Correct.
na?
Mm. Mm.
Because whatever you applied here, that is on the previous structure. Now, when you
Mm.
alter the structure, then you have to redo
It will
all those
affect all
tasks.
the dependencies.
So, how many man hours will be lost?
Mm.
There is many. There are many.
Mm.
Okay. So, before going to apply this database into application development, we must be
Mm.
very sure that our database design has no problem
Mm.
in it, has no
Okay.
discrepancies. Means
Mm.
the
Errors in that.
not exactly errors. Okay, a
Mm.
wrong
Like it,
design
the
is
functioning
not
wise.
necessarily
Mm.
tell you the
Struct
that this is an error. Okay, but maybe some
precise
problems.
structuring.
Okay,
Mm.
that problem
Precise
may
structuring.
occur while you are developing your application.
Mm.
So here comes the importance of normalization. Normalization is a certification process which gives you
Mm.
a guarantee that these problems will not occur in the database while you are developing the application or while the application is being used by the user. Okay, so
Mm.
normalization is a certification process for the database design. Okay, it
Mm-hmm.
will give you some guarantees. Okay,
Mm-hmm.
so we say that we have mm, 6 plus 1 normal form of database, normal forms. Okay, means simply we have 7 certificates in database design. 6 plus 1, 7 certificates. What are they? Those are first normal form. Just listen. After that, you will understand. First normal form. Then we have second normal form. We say like that. Then we have
Okay.
third normal form. Often we say that This is 1NF, 2NF, 3NF. We pronounce it like that: 1NF, 2NF, 3NF, or first normal form, second normal form, third normal form, like that. Okay. Now,
Okay.
suppose you have a database. Okay. You have to confirm which normal form your database design is belongs to. Okay. You have to confirm after designing a database. Roughly, you design a database. After that, you have to certify yourself that your database is up to 1NF or 2NF or 3NF. Means your database is satisfying 3NF. Okay. So when you are giving your database design to the company, or you may say the client, okay, after designing the database, you have to discuss the database design with your client too. Okay, client should approve. Okay, this is the database, or maybe the development team, or maybe your project manager, right?
Mm. Right.
So you have to specify in which normal form your database design belongs to, right? Now, if you are saying that my database design belongs to 3NF, then automatically you are saying that your database belongs to 1NF and 2NF too. So a database belongs to this 3NF. Okay, a database
Mm.
hold these
Mm.
3NF these are the certificates. Okay,
Okay.
when you are saying that your database is in 3NF, that means you are certifying your database. Okay, so
Okay.
when a database is in 3NF, it automatically approve 2NF and 1NF. Right? Just listen. Now see,
Okay.
you can tell me, yeah, how can I understand that my database is in 3NF? Okay, there are some checkings. There are some rules. That rules need to be satisfied on your database design to become in
Okay.
1NF or in 2NF or in 3NF. Okay, as you
Okay.
go in this line, the rules become stricter. Okay, stricter rule. So if those rules followed by your database design, okay,
Mm.
then you can say your database is normalized.
Okay.
If these rules follow by your database, then you can say your database is normalized database. And we develop our application using only normalized database. If your database is not
Mm.
normalized, then there may be lots of problems. Even a complete project um, scrap may happen. Okay, complete
O-
project scrap
Okay.
may happen after, means what is project scrapping? Means after development, the client is not agreed to
Disapproves.
taking that database because there are many
Mm.
problems. And when you are going to alter all those problems after development, that is a huge task. And that is that time it is better to develop a new one
Then altering.
than altering the older one. Okay, so that is project
Mm.
scrapping that may happen due to a wrong database design. So
Mm.
normalization is a certification process. Normalization is a process through which you check some rules, whether those rules are satisfied by your database design, and depending how many rules you have maintained in your database, you have 1NF, 2NF, 3NF. Okay, you have more. The next one is your BCNF. It has a full form, voice code normal form. We will discuss. After that, you have 4NF and you have 5NF and you have 6NF. So altogether, you have this 6 plus 1. This one is special, BCNF. So 6 plus 1.
Okay.
You have 7 certificates for your database. Design, not database. You have to say database design. Okay. Now to know all these database means normalization processes, you have to know the rules. Okay. So which are the rules? How we should check to say that our database is in this normal form. Okay. So after normalization is completed, you have to specify in your project report that my database is like this. My database is up to 3NF or up to BCNF or it is satisfying 5NF. Okay, like that.
Okay.
Is it okay?
Fine.
Okay. Now, in today's development process, these three normalization is must means every
Okay.
database must be normalized up to 3NF, you can say.
Okay.
Okay, and in some cases BCNF too. So 1NF, every database is already, we think database in 1NF pattern. Whenever we are thinking about a database design, we think in 1NF. After that you have to satisfy the 2NF conditions and 3NF conditions. So 1, 2 and 3NF are quite, you can say,
Mandatory.
mandatory for today's development
Mm.
area. Okay,
Okay.
okay.
Mm.
So you get an idea now what is a normalization, what is normalization,
Yes.
what is all about.
Yes. Yes.
Okay, now see what they are saying. Hmm. Good relational schema means normalization process gives you a definition that you can say your database design is good relational schema. Okay,
Mm.
if it is not normalized, then you cannot say that my database design is good. It may be good, it
Correct.
may not be good, but if your database design satisfy the normalization concepts or conditions, then you can
Mm.
say okay, my database design is good. Okay,
Okay.
this is the some informal guideline of relational database. Informal guidelines means there is no hard and fast rule designing a database.
Okay.
Informal
Mm.
guidelines. This is clearly copied from that book, Elmasori Navaki.
Mm.
Informal guidelines. Okay, means you can say these
Conventions.
are maintained as a thumb rule. It's not hard and fast rule. It's there is no
Mm.
constraint.
Conviction.
Okay,
Convention, we can say.
hmm. It's not like that. If you
Mm.
do not follow these rules, then you have a very much problem. The task will not be done at all. Okay,
Mm.
obviously the developer can work on the wrongly designed database, but at the time of development, the task for the developer will become very huge if your database design is not normalized or not correct in this uh, scenario. Okay, if your database design is not normalized or not you are not created you have not created the database by following these rules, then the development tasks will become more complex. Okay, and we
Mm.
do not want
Okay.
to make the developer's task a complex one. Okay, so that's why
Okay.
normalization is necessary. It will shorten the task of developers. Okay, now look into this point, semantics of relational attributes. What do you understand by semantic of relational attributes? It's very simple. Semantic means meaning, you can say semantics means meaning.
Mm.
Relational attributes means whatever the attribute, you remember the term attribute in the table,
Yes.
the column
In the
names are
table variables,
attribute,
the
huh?
columns are attributed.
So this line tells you that whenever you give a name to an attribute, it must be very
Meaningful.
precise, meaningful name. You just
Mm.
give you should not give a name like age. Okay, a
Mm.
column where you are storing the age of employees, just like that age AG. Okay,
Mm.
so by giving a name to the attribute AG, only you can
Mm.
understand that this column is for age.
Name is
Nobody will
age.
understand. Okay, so give a proper name. That is the
Mm.
that is this line. Okay, now you can
Okay.
understand if you do not follow this rule, then what will happen? Will it not be possible to develop an application? Obviously, the
We can
application can be developed,
obviously.
but the developer must find out a AG. What is the meaning of AG? Just call the database designer and ask her what is the meaning of AG. Okay, so thing is like that. Okay,
Okay.
redundant information in tuples and update anomalies. Update anomalies is something which I will tell you later. Redundant information
Mm.
means your database design should not be in that way that you are getting redundant information in your
Duplicate
tables.
data.
Okay, so one information is coming multiple times in your tables.
Re-
Redundant means
Duplication of
multiple,
data.
repeated, duplicate data.
Mm.
So,
Mm.
this is one rule. So your database design should be
Mm.
in that way that redundant
Mm.
information is not present in your database, or if it is present, then the number of occurrence will be minimized. Okay,
Mm. Mm.
so that is the rule. Again, you can understand that if you do not follow this rule, what will happen? The developer's task,
Duplicate. Accuracy
developer
will be less.
developer need to identify, means he need to implement a logic to remove the redundant information and get one single information from that. Na?
Mm.
So without maintaining this rule, it doesn't mean that the task is not possible. Obviously, the task is possible, but the developer's task will become more complex like that. Update anomalies.
Mm.
Anomalies means some, mm, you can say mishaps or some, क्या कहते हैं? What is anomalies? Exactly meaning of anomalies means some problems. Okay.
Okay.
So update anomalies are of three kinds. Hope they are discussing update anomalies later. Insert anomaly, uh, update anomaly, and delete anomaly. Means when you are going to insert a data in a table, you are facing some problem. When you are deleting some data from a table, then you are facing a problem. Now when you are updating some data in a table, you are facing a problem. So these three
Mm.
types of problems together called update anomalies.
Okay, like in primary key by mistake, if the user wanted to delete or update with us,
Huh.
it
We will
could be
see
an
it later.
example, right?
I hope that update anomalies are discussed detail.
Okay.
Null values in
Okay.
tuple. Your database null values in tuples. Your database should be designed in such a way that you have minimum number of null values in your database. Okay. ये कैसे लिखा है null values in tuples means what? Informal guideline. It should be written like that. Null values. Okay. Null values in tuples is means that your database design
Mm.
should be in such a way that it
Mm.
contains minimum number of null values. Okay. Null
Okay, we should
values.
avoid.
Should avoid null values. Okay. Now I can take an example and describe all these things.
Mm-hmm.
Let's see. Spurious tuples. You know the term spurious?
Yes, previous
Some
chapters. Yes,
erroneous
and one
tuples, extra
whenever we
tuples.
are
That
joining a
should
table, we get some
that should not
inaccurate
be.
data.
When you are
Mm.
making a Cartesian product, then spurious tuples may arise. But
That should be sorted out.
huh, that should be filtered out.
Mm.
Okay. That is
Mm.
not the case here. They are saying that your database design should be in such a way that minimum number of spurious tuple or uh, no spurious tuple will be there at all. Okay.
Mm. Mm.
So your database design should be in that way that it should not contain any spurious tuples, because spurious tuples means some extra tuples which are containing wrong informations. Okay. Okay, move forward. Let's see.
Okay.
Semantics of Ocha. Okay, they are describing it here. Semantics of relational attribute means
Okay.
what? Now you just read it
Mm.
and you can understand easily. Okay.
Yes, yes, we can understand.
Redundant information tuples and update anomalies. Look at here. Update anomalies are of three types:
Insertion, deletion.
insertion, deletion, and modification or updation. Okay.
Mm.
Two relations are from. I am giving you a little example of update anomaly. Three types of
Okay.
anomalies. Okay. Just see here. Important. Uh, Maybe I have to write something. Say I have SSN. You remember the table name, na?
Yes. Genuine.
SSN.
Ine.
Say SSN F name L name. कितना ही रहने देते हैं? अच्छा, सैलरी बस और कुछ नहीं, और डीएनओ।
Again.
ठीक है।
Mm.
अच्छा, डीएनओ के साथ डीएनओ हम नहीं रखेंगे, यहाँ पे हम ऐसे करते हैं
DPT.
डीएनओ
DPT.
और डी
DPT.
नेम। क्या लिख रहे हैं? डी नेम and DMGRSSN. Okay. Now what we did here, we are we are taking two tables in consideration. One is your employee and another is your department, if you remember.
Department.
Okay.
Yes.
We are combining the two table. Suppose our database is designed in that way. Okay. Then what will
Mm.
happen? Then what will happen? If our database are designed in that way, okay, then what will happen? Okay, just a minute. For your remembrance, I am showing you the company schema. See here, this is emp table. You have ssn, fname, lname, salary. Okay. And
Yes.
you have jdept table where you have d number, d name, and dmgrss.
Rename and destination.
So
Mm.
here you can see we have two different tables, two separate tables. This table is
Yes.
containing the information of employees. This table is containing the information of departments.
Departments.
But
Mm.
here we are taking one table. Okay,
Joining to
we are taking one table where the information from employee table and the department table are
department
put
table.
together. Okay,
Okay.
this design is wrong. It's not
Mm.
error. You cannot say that this
Mm.
is an error. This is a wrongly
Mm-hmm.
designed schema.
Mm-hmm.
Okay. Now, what is
Mm-hmm.
the problem in this schema? That you can see
Mm-hmm.
here. First, we
Mm.
discuss about insertion anomaly, right?
Yes.
Insertion anomaly. Anomalies are of three types. Anomalies means problems.
Problem. Mm.
Anomalies. Okay. Some problems. कहते हैं ना
Mm.
गंडगोल, आप नाम सुना है? मतलब in your language what is the term? Means problems means some common problems. हम लोग जैसे कहते हैं कि गोलमाल. Okay.
Okay.
गोलमाल, you know the term गोलमाल?
Yes, yes. I have heard that in our language also we use that. In
अच्छा,
Kannada
गोलमाल
also
है.
that term
हाँ,
is
तो
there.
anomalies is
Golmaal
something
is
like
there.
that, गोलमाल. Okay.
Ah,
Some garbar will happen.
yes.
So what is the
Ah,
garbari or the golmal? See here,
okay.
suppose you want to enter the information of an employee, right? Now, when you are going to insert an information of an employee, so you have to give the name, say Shashikala and Iyer, na? Your
YL. YL.
YL.
Mm.
Acha. You put a salary. Now see, when you are entering an employee details, you have to
Mm.
put the department details also.
Yes.
That becomes mandatory in this structure, na?
Yes.
Okay, now you can say, what is the problem? Give the department. Say I am working in department number 10, and the department
Mm.
name is research. Okay,
Mm.
and the manager of department is someone like that. Okay,
Mm.
no problem. Okay, no problem. Suppose we are entering some other person, say Srinivasan.
Mm.
Anyway, कुछ उसका salary है. We are putting some
Mm.
salary. Now suppose
Department
Srinivas
number.
is a fresher. Okay,
Mm.
he's just been appointed by the company, but he is
Mm.
under no department right now.
Probationary
We
period.
have not
Mm.
we have
Allotted
not
any
assigned any
department.
department to him. Okay,
Mm.
you know that department initially when the employees are taken in a MNC, they put in a training. Okay, that time,
Yes. Probationary period.
that time the department is not allocated to them. Okay, they are just
Mm-hmm.
having their training and all. So what you
Mm.
have to enter here? Now here, as per the design is saying, you must enter something.
Enter a D number.
Otherwise, you
Mm.
have to put null. Huh?
Mm.
So null here, also null here,
Mm.
and null
Here
here.
also the null.
Now
Mm.
look, as per our guideline, we have been told that your design should be in that way that you have minimum number of null.
Null. Mm.
But here we have made a design in that way that we may
Yep.
have many null. Na? Suppose in 22 batch, this
Mm.
company is going to adopt say 1,000 employee. Okay, so all
Mm.
those thousands employee are freshers. They are going,
Yes.
they are having their training for say 2 months, and
Yes.
throughout these 2 months, all these 1,000 into three fields means 3,000 fields
Will be
will
in.
be a null.
Will. Null.
So that is a big mistake, wastage of memory,
Mm.
right? So this is
Yes.
the problem. Okay.
Okay.
Now again,
Okay.
suppose in your company you are going to
Mm.
uh, launch a new department. Okay, you are going to
Mm.
launch a new department, say 11, number 11 department, that will be a sales department, but
Mm.
you are not assigning any manager to it.
Mm.
But when you are entering this department information, what you will put here?
Null.
You cannot leave this thing empty
Yes.
because that will be a single tuple. So again you
Okay.
have to put null. Look,
Mm.
what is the goalmal here? So we made this design in such a way that null is very
Occupying
obvious
more.
in every case. Okay,
Mm.
hence this is a problem to this database design, and
Mm.
this is called your insertion anomaly. Means when this anomaly occurs, this goalmal occurs when you are going to insert the
When
data, and that is
record.
termed as
Mm.
insertion anomaly. Is it okay?
Mm-hmm. Yes, sir. Got it.
Mhm. Now the next is your deletion anomaly. Now what is deletion anomaly? Suppose this person, this SYL, okay,
Mm.
is an employee. She is just means leaving the company, means he
Mm.
resigns from this company.
Mm.
Okay,
Mm.
and she is the only person working is this department. Okay,
Mm.
so when she is leaving the company means she is resigning, so we have to delete
Mm.
this record.
Yes.
Now look, when you are deleting an employee, you are also deleting the department
The
information.
department.
That is a big
Mm.
mistake. That
Mm-hmm.
should not be take place now. You are not removing the department, you are just removing the employee.
It's
But
employee.
unfortunately, while removing the employee data, your department data is also
Removing the
removed.
department data also.
So that is again a
Okay.
golmal. Barabar.
Mm.
And that golmal take place. Why? Because you are deleting. When you are
Structure.
deleting a data, that's why it
Mm.
is termed as deletion anomaly. Right.
Mm.
Next is your modification anomaly or update anomaly, you can say.
Mm.
Now, this is something like that. Suppose you have, say, 1002 ST 50 department number 2. Say some department is, say, production, and DMGR is, say, 102. Okay. Suppose
Mm.
we have some other data here, and we have another 1015, say MD, say 100. So again, this is 2. This is production department, and the manager is 102. Okay. Now look here. Suppose the manager for this department is changed from 102 to
Mm.
115, right?
Mm. Mm.
So, and in this department, maybe you have multiple employees. Like that, here you have 2 employees. You may have 200 employees for this department. So you
Mm.
have to alter the data in all those
Of
200
200.
records. It is a huge task. You have to find the 200 records, and you have to alter the data. If by
Mm-hmm.
mistake any record remains unchanged
Mm.
for this department,
Mm.
if by
Mm.
mistake any record
Mm.
remain unchanged
Mm.
for this department, then what will happen?
Mm.
Then your database will
And
become inconsistent.
inaccurate. Inconsistent.
Inconsistent, the right term is inconsistent. Okay, later in
Mm-hmm.
acid property we will know what is inconsistency, but
Mm.
here
Mm.
your database become inconsistent. Why it is inconsistent? Because in one record
Mm.
it is showing that department 2 is managed by this employee, and in other record
Mm.
department 2 is managed by this employee.
Mm.
So that is inconsistency, and that should not be tolerated in database design. And I am saying
Mm-hmm.
that this may happen. I'm not saying that this will happen. If I say that this
Yes.
will happen, then that is a error. That we can say that that is error,
Mm.
but these are not errors. Okay,
Mm.
these are some problems. These are some gulmal that may happen if you are not
Mm.
designing the database, maintaining the thumb rule or those
Mm.
guidelines. Okay, informal guidelines. Okay,
Mm.
if you are not following these informal guidelines, then these type of problems may happen in your database. Tell me if you understand
Mm.
properly these things, anomalies.
Yes. Got it.
Okay, fine. So normalization, process of normalization is the way how you can guarantee that your database will not face any anomalies, neither
Okay.
insertion nor deletion nor modification. Normalization process, you can
Mm.
define normalization process in that way also, that it is a process which will give us the
Mm.
guarantee that the anomalies will not take place in our database. Okay,
Okay.
you are getting the things now.
Yes, I'm able to understand.
Okay, okay, just you read this after a class, you read this PPT and
Yes. Fine.
listen the video once again, you will get everything out of it. Update
Okay.
anomaly, then null values in tuple. I told you spurious tuples. You already know. See, appears in case of join.
Yes.
Okay,
Mm.
spurious tuples. We did this earlier. Now here comes the term functional dependencies. That is a big thing. Okay, so up to this, what we have learned, we have learned that there is something called normalization. What is normalization? Although they have not speak anything about normalization here, no problem.
Mm.
I told you initially what is normalization, what is our purpose in this unit. So our
Okay.
purpose in this unit is to certify our own
Certify the
database design. Okay, what are
mm.
the different normalization
database design.
certificates or normalization forms?
One F, one N F, two
Then
N F.
we have what are the different design issues that may take place, what are the
Mm.
anomalies. Okay,
Anomalies.
now we will discuss something called functional dependencies. Functional dependency, or you can say FD. Now what is FD,
Mm.
or functional dependency? See, uh, you are dependent on, you are depending on, say not you, we all are dependent on doctors now.
Yes.
When we have some physical problems or some health issue, we are dependent on doctors, right?
Correct.
Acha. Suppose we are dependent on the university to get the certificate, right?
Mm.
Now you
Yes.
cannot say that we are dependent on everything on doctor. We are dependent for everything on doctor. We cannot say like that. Okay.
Correct.
You are not dependent on the university for everything, right? You cannot say like that.
Yes.
These dependencies are called functional dependencies, right?
Mm-hmm.
But you can
Okay.
say that your child is dependent for everything on you till now,
Mm.
because they are
True.
infant or
Mm.
they are a student life, belongs to student life. So the mostly they are dependent for everything on their parents. Okay.
Yes.
So functional dependency means dependency of somebody on something.
Or something.
Okay,
Mm.
functionally for a specific type
Mm.
of purpose.
Functions. Mm.
Here, a database, in a database, in a,
Mm.
sorry, in a table. Okay, not in a database. In a table,
Okay.
we have many attributes. Say
Mm.
x, y, z, something like that.
Mm.
So these attributes have some dependencies among themselves, may have some dependencies. These attributes
Mm.
may have some dependencies among themselves. Now, what that means? Suppose I write that X is an attribute. You can say X is a set of attribute. You can also say like that. If X is a set of attribute, I am taking here just like X is a single attribute, Y is also a single attribute. When I am saying that X arrow Y, this is the symbol, arrow symbol, okay? Dependency symbol is like that, arrow.
Okay.
We read it like that, X determines Y. How we read it? X determines Y.
Why?
X determines Y. Or we can say Y is
Depending on X.
determined by X. Or we can say X, sorry, Y is functionally dependent on X. Okay, in this three way we can read this line. X determines Y. Usually we read like this, X determines Y. Okay, what that mean? X determines Y means it's very simple. Whenever you know the value of X, you can determine the value of Y. Whenever you know the value of X, you know the value of Y.
Value of Y.
That is dependency. Okay, now if you and me make an arrangement like that. Whenever I say 1, you will tell me 10. Whenever I say 2,
Mm.
you will tell me 20.
Mm.
Means there is a
Mm.
rule. So whenever I tell you n, you will tell me n multiplied by 10. Na?
10. Yes.
So clearly, I can say this is dependent on this.
Dependency is there.
If I tell you 5, then quickly you will tell me 50. So can't I say that there is a rule? This is called dependency. Okay. Whatever you are
Okay.
saying is dependent on my information, my data. So that is dependency. I'm trying to make you understand. Are you getting
Yes.
the thing?
Got it. Got it. Got it.
Okay. Now, formally we can define it like that. Suppose you have a tuple T1 and tuple T2 in a relation R where X and Y are two sets of attributes. Okay. Then X determines Y means whenever you have T1 of X is equal to T2 of X, then we must have T1 of Y is equal to T2 of Y. This is very simple, some mathematical notation. Means what? If I say that this relation schema, capital R, which contains these two sets of attribute X and Y,
X and Y.
and among them, between them, there is a relation X determines Y, then we must have this condition follow. Means if we have two tuples in this relation and if their X attributes are same, then obviously we can 100% sure that their Y attribute will also become same.
Also,
Now how can we explain it? Suppose I am taking an example, just to say employee. Okay. In our
okay.
employee data, say where it is. Suppose we are taking this example. Okay. Now here see, this is your primary key. Na? You already come to
Created a
know.
primary key.
Hmm.
Hmm.
Primary key. So I can say that if name is dependent on SSN. Why? Because if I tell you that 1005, okay, whenever I
Then
tell you SSN of 1005, sorry, SSN is 1005, then what will be the F name? Then you have to say Cheteshwar,
correct.
right?
Yes.
So here you can see that whenever
Dependencies
you are
there.
specifying an SSN value, you have to specify the respective name. You cannot say that if I tell you the SSN is 1008 and you are saying F name is Ravindra. No, you cannot say like that. Okay. So this is the significance of functional dependency. We can say that SSN determines F name. Okay.
Okay. Okay.
But look here, we cannot say F name determines SSN. We cannot say F name determines SSN because if you
If
say
name
like that
two
F name
name
determines
can
SSN,
be
then there may be
two
two
name
Rahul. Say Rahul
two
Dravid and Rahul Lokesh Rahul. Okay, Rahul Lokesh. So do two players or two employees can have same F name, but their SSN will be different. Okay. If you have a rule in this table like that, every F name have unique SSN value, then you can say F name determines SSN. Means if Rahul, F name is Rahul, then the SSN will be 1002. Are you getting the thing? Same thing like that. You cannot say F name determines L name. Okay. Why? Because if you say F name determines L name, then whenever you have Sachin here, you must have Tendulekar in the L name. But is it
L
possible?
name. No.
Some other employee may have the name Sachin, but his or his L name
Last
may be
might
different.
be different.
So in that way, we cannot say F name determines L name. Okay, so this
Mm.
is the
Correct.
significance of dependency. By using dependency, we are specifying the key value. Okay, so dependency means SSN here. See, SSN determines everything here. This SSN determines everything. So for this employee, if you take this here, you have to say like that. SSN determines FNAME, LNAME, CT, salary,
Salary. D
super
number.
SSN, DNO. What this mean? Simply I can say, I can tell you, this is a very simple thing. That means if you have been provided with SSN, then you can provide this information. Okay.
Correct.
Dependency means is that. It's very simple. If you are given with your SSN, then you can tell this
Provide all the
information.
correct data of those are the remaining attributes.
So that is your functional dependency. Okay.
Dependency. Mm.
Now functional dependencies are of two kinds. FD. Functional dependency we usually write it in short form FD. Two kinds. One is your partial dependency and another is your full functional dependency and partial dependency. Now what is full functional
Mm-hmm.
dependency and partial dependency? See, if X is an attribute, I am writing the partial here, huh? So if X
Okay.
is an attribute, a set of attribute, okay, and we have another set of attribute Y which is dependent on X, we can write like that. X determines Y, right?
Yes. Yes. Yes.
Now consider you have an attribute A, capital A, which belongs to X. Capital A is an attribute which belongs to X, right? Now if you are subtracting A from X, but still the dependency remains, dependency holds good, holds, then we can say X and Y is a partial dependency. I am repeating.
Okay.
So X is a set of attribute. Okay.
Mm.
So X is a set of attribute. Y is also a set of
Mm.
attribute.
Okay.
Now, in that set, I am taking an attribute, assume an attribute
A.
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 So if you
It
remove
belongs
that
to.
A from X, okay,
Mm.
but the dependency will still exist. Means removing an
An
attribute from the left
attribute.
hand side
Mm.
does not affect the
Mm.
dependency. Then
Okay.
you can say
Mm.
that this Y is
Yes.
not fully dependent on X. Na? It is
Correct.
the
It is a
dependency is
party.
partial.
Partial.
Means
Mm.
the Y is dependent on some values of some attributes of
Other
X, not on X.
X.
So that dependency is partial.
Mm.
And full functional dependency is just the reverse. Say X and Y
If
is a dependency. Okay. A
it
belongs
will
to
affect
X,
the. Uh,
but if you remove A from X, then the dependency
mm.
does not hold anymore. Does not hold anymore. Then we can say that this dependency is full functional dependencies. Means you cannot
Remove
remove
that
anything from
attribute.
X in order to hold the dependency.
Mm.
That is called your full functional dependency.
Full.
Is it okay?
Okay. Now in the previous example, SSN number, if you remove the full dependency will go. That is
Obviously, in
a
SSN
fully
number,
dependent.
you cannot understand from this one. You can
Hmm.
understand it from some other example. Say, suppose in a school environment, school student database. Okay,
Hmm.
so in a school student database, we have primary key something like that: role, section, and class. Na,
Yes.
I can say in this order. In a school, we have a
Hmm.
class. Say class 9.
Hmm.
Every class has some section. What you
Okay.
will do in a school to find a specific student from the school? You have to
Class and
specify
section.
class, you have to specify section, and also that after
Then
that you
roll.
have to
Roll.
specify the role.
Roll number. Hmm.
If you specify at least these three, then the other fields can be searched for.
Oh.
Okay,
Okay.
so in that way we can say that in this school, class, section, and role, I'm writing in
Roll.
short,
Hmm.
together determines all others. Okay,
So that is having a
this is
full
a full functional
dependency.
dependency, because if you remove any attribute from this set, this dependency will not hold. Okay,
Hmm.
but consider this is full functional dependency. Full functional dependency. But consider in this case, in this case, SSN determines this one. Okay, can we write that SSN and F name together determines the rest? Means,
No.
can't we write that SSN comma F name together determines
Ah,
all
we can
others?
write. Hmm.
We can write that this is, there is no problem. See
There
here
is no
SSN,
problem, but only SSN
SSN,
will be sufficient to determine the.
SSN is sufficient to determine the other attributes, other values. There is
Hmm.
no need of fn, so we can remove this fn, but still the dependency holds. Okay, so this dependency becomes a partial dependency. Okay, this way you can differ full functional dependency and partial dependency. Getting it?
Got it.
Okay, functional dependencies are all about like that. The example of fd constraint. Okay, now see, in a particular database, something like that, in a particular database, okay, there are multiple tables, and in every tables we can have multiple fds. A single table can have more than 10 to 15 fds, or maybe more than that. Okay, this single table have at least 10 functional dependency here. So
Okay.
all the tables together form a set of functional dependency, we can say.
Yes.
So that functional dependency, we can say, is a, it is a set of functional dependencies for this schema, and we
Okay.
determine that set, means we use that set as f. Okay, set of functional dependencies. This is a set of all functional dependencies. Sorry, set of functional dependencies, essential functional dependencies, we can say. If for any particular table we can have a set of functional dependencies that is termed as f. Okay, but we can have a set of
Okay.
all functional dependencies available in that particular schema.
Hmm.
This is called closure set of functional dependencies. This is called
Close.
closure set of functional dependencies.
Okay.
This is called set of functional dependencies, means the essential set of functional dependencies which are mostly required. Okay,
Okay.
maybe you have 10 functional dependencies here, and from that 10 functional dependencies you can have 1,000 functional dependencies here available. So this is the set of all functional dependencies that may be possible in that relation, and that is called a closure set of functional dependencies, denoted by f class.
Okay.
Okay,
Okay.
How can we determine all those functional dependencies? Although we do not require those all functional dependencies, but we can determine these functional dependencies. That can be determined by using some rules. Those rules are called inference rules. There are 6 inference rules. See here, inference rules. Armstrong axioms are
Okay.
some inference rules. The first 3 inference rules are called Armstrong axiom. I will tell you later. But what is inference rule? Inference rules are some rules, very simple rules that are used to determine this closure set. Okay. Infer means you know na infer.
Huh.
So from these functional dependencies, you can infer all other functional dependencies. Okay. By using some
Okay.
rules. Those rules are termed
Hmm.
as inference rules
In
of RDBMS or DBMS. Okay, but we will do it next day. I have to go now. Okay,
no problem. No
so
problem. But thank you
we
so
will
much. At
we will
least we have
continue
covered,
from
I think.
inference rule in the
Uh,
next day. Okay,
so how many slides were there in?
so here
Okay, close. No problem.
we have slides. They have many slides, but
Content,
I
I
will,
think.
yeah, I will tell
Mm,
you these things. These are very simple things. If you understand, uh,
I think in one more class we can finish up this,
yeah,
right?
yeah, 100%. We have to do it.
Okay.
Okay,
Okay.
okay. So hope we will meet again on next Wednesday.
Yes, in the weekdays we'll do something. We'll do
Mhm.
definitely.
Wednesday
If it
or
is little bit late, also I will just join. I'll check the availability of yours.
yeah, yeah. Do it. Okay.
Okay.
Okay, Shashiji.
Good
Thank you.
night.
Good night.
Thank you so much. Good
Okay.
night.
Okay.